Geochemical classification groups elements based on their chemical and physical properties and their behavior during geological processes. Siderophile elements. These iron-loving elements, like iron, nickel and cobalt, have an affinity for metallic iron and are found predominantly in the Earth's core. Lithophile elements. These rock-loving elements, such as silicon, aluminum, potassium and sodium, have an affinity for silicate minerals and are abundant in the Earth's crust and mantle. Chalcophile elements. These sulfur-loving elements, for example, copper, lead and zinc, have an affinity for sulfur and are commonly found in sulfide minerals. Atmophile elements, these so-called gas-loving elements, include nitrogen, oxygen, hydrogen and noble gases. They are predominantly found in the Earth's atmosphere and hydrosphere. Abundance of elements in different Earth compartments. Bulk Earth. Oxygen makes up about 29.5%. Iron constitutes around 34.6%. Silicon accounts for approximately 15.2%. Magnesium is about 12.7%. Sulfur comprises around 2.9%. Nickel represents about 2.6%. Calcium is around 1.4%. And finally, aluminum makes up about 1.1%. Earth's crust is composed predominantly of a few key elements. Oxygen makes up about 46.6%. Silicon follows with roughly 27.7%. Aluminum accounts for around 8.1%. Iron is about 5%. Calcium is approximately 3.6%. Sodium comes in at about 2.8%. Potassium is around 2.6%. And finally, magnesium makes up about 2.1%. Now, let's dive into the hydrosphere, specifically the oceans. Oxygen is the most abundant element, constituting about 85.8%. Hydrogen follows with roughly 10.8%. Chlorine is about 1.9%. Sodium is around 1.1%. Magnesium and sulfur each make up about 0.1%. Calcium and potassium each contribute approximately 0.04%. Moving on to the biosphere, we see a different distribution of elements. Oxygen is the most prevalent, accounting for about 65%. Carbon follows with roughly 18%. Hydrogen is about 10%. Nitrogen makes up around 3%. Calcium is approximately 1.5%. Phosphorus is about 1%. Potassium is roughly 0.35%. And sulfur is around 0.25%. Partitioning of elements during surficial geologic processes. Elements are redistributed between different reservoirs like rocks, soil, water and the atmosphere during geological processes such as weathering, erosion, sedimentation and volcanic activity. Weathering breakdown of rocks releases elements into soil and water. Erosion. Transport of weathered materials moves elements from land to bodies of water. Sedimentation, deposition of particles in water bodies, leading to the formation of sedimentary rocks. Volcanic activity releases elements from the Earth's interior to the surface and atmosphere. Geochemical recycling of elements. Geochemical cycling involves the movement and transformation of elements between different Earth compartments, such as the crust, mantle, hydrosphere, atmosphere and biosphere. Carbon cycle. Carbon moves between the atmosphere, hydrosphere, biosphere and lithosphere through processes like photosynthesis, respiration, decomposition, weathering and volcanic activity. Nitrogen cycle. Nitrogen is cycled through the atmosphere, biosphere and lithosphere via processes like nitrogen fixation, nitrification, denitrification and ammonification. Water cycle. Water is cycled between the atmosphere, hydrosphere and lithosphere through evaporation, condensation, precipitation and runoff. Paleoclimate. Paleoclimate studies involve the reconstruction of past climate conditions using geological and biological proxies. Ice cores, analysis of trapped gases and isotopes in ice layers provides information on past atmospheric composition and temperature. Sediment cores, examination of sediment layers and their chemical and biological content reveals information about past environmental conditions. Tree rings, dendrochronology uses tree ring patterns to infer past climate conditions such as temperature and precipitation. Fossils. Study of plant and animal fossils helps reconstruct past climates based on the species' known environmental preferences. Conclusion. Understanding the geochemical classification of elements, their abundance in different Earth compartments, and their behavior during geological processes is essential for comprehending Earth's dynamic systems and history. Paleoclimate research further aids in understanding how the Earth's climate has changed over time, providing insights into future climate trends.